Hello, geometry students. This is Miss Glenn, and today we're going to be talking about the probability of multiple events. So the key word that we're using here is then. So one event, then another event happened. So to start off, we're going to build this up using logic. So first we want to think about two pretty small events that we want to consider. So let's consider we're flipping a coin and rolling a six-sided die. In this situation, we want to know what's the probability of flipping tails on the coin and then rolling a six. So in order to do that, we need to think about two different events here, flipping the coin and rolling the die. So let's think about each event individually. If I think about flipping tails on a coin, what's the probability that I flip tails on a coin? There are two options. You either flip heads or you flip tails. So my total in this situation is 2, and flipping tails is one of those two options. So the probability of flipping tails is 1/2. Then for a dice, there are 6 different sides to that dice. There's a 1, 2, 3, 4, 5, and 6. And the 6 happens to be one of those sides. So the probability of rolling a 6 on a dice is 1 out of 6. But that's each event individually, separately of one another. What do I do with these two numbers when I want to put those two events together? Let's think about all of the possibilities of what could have happened if I did these two events together. I could have rolled a 1 on the dice, and either I got heads or I got tails on the coin. I could have rolled a 2 on the dice, but the same situation. Oops, that's in a weird place. I could have rolled a 3 on the dice, and same situation with the coin. Oh my goodness, my options are all over the place. I could have rolled a 4 on that dice and either gotten head or tails for the coin. I could have rolled a 5 and same situation with the coin, or I could have rolled a 6 and gotten the coin to either land on head or tails. So now, in the really janky fashion that it exists on my screen, we have a total of, I'm going to use my pointer here, 1, 2, 3, 4. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options. We have 12 total options. Nope, I'm not going to do that. I'm going to just write it out with my hand. And the one situation that we're looking for is that one right there. So out of, let's just write it out because I don't know what's going to show up behind this. Out of 12 total options, our desired event was this one, Our desired event was T6, which is 1 out of 12 total options. So the question that we then want to think to ourselves about is, how does that 1 out of 12 relate back to the 1, there we go, relate back to the 1/2 and the 1/6 from the previous page? Well, if I clear off all of my markings for a second, let's go back and look at some more words. So let's clear my markings and look at some more words. So the answer here is 1/12, which we just decided. And how does that relate to the 1/2 and 1/6 from the previous page? Well, it turns out that 1/2 times 1/6 is equal to 1/12. Coincidence? Let's check it out. Let's try another one. Now let's think about the probability of rolling a 5 on a dice 2 times in a row. So rolling a 5 and then rolling another 5. 2 separate times that you're rolling a singular dice. So if we think about the events that would be happening here, come on. In this case, there's a lot of situations to consider. We actually wrote out a chart very similar to this when we played Blocko back on day 1. This time we're considering rolling the same dice twice, so it's a little bit different of a scenario. But the situation that, again, we would be looking at would be this one right here, getting a 5 and then a 5. So that is 1 out of the 36 options. So in general, to roll a 5 is a 1 out of 6 probability. To roll a 5 again in the second event is also a 1 out of 6 probability. So how does that 1 out of 6 and 1 out of 6 relate to the answer on the last slide, which is 1 out of 36? Well, it's multiplying. We decided that 1/6 times 1/2 on the last slide worked out, and it works out yet again. And it turns out that's not a coincidence. If we have more than 2 events, this property still holds. And eventually we will stop writing out all of the events like we did on this slide, and we'll just start using this rule. So when we have the probability for 2 events, it's the probability of the first event times the probability of the second event. Then if you have 3 events, then we multiply by the probability of the third event, and so on and so on. So when we have these multiple events, what we do to combine each of their individual probabilities is we multiply. So that's our first rule. And then the only other thing that we need to consider when we're thinking about these multiple events is asking ourselves this very important question. Will the second event be affected by the first event? And a scenario that we're going to look at to help us discover this is thinking about M&Ms. So imagine a bag of M&Ms, a really large bag of M&Ms. There are 57 M&Ms in that bag. Let's assume there were 7 that were red, 7 that were brown, 8 that were yellow, 14 blue, 11 orange, and 10 green. And in this situation, your favorite color of M&M is the brown M&Ms. They're the best. According to a character in the wedding planner, they have the least amount of artificial coloring because brown is the color of chocolate. Not true, but nonetheless. Your favorite color of M&Ms is the brown ones. But they have the lowest probability of being pulled. There's only 7 brown M&Ms in this huge bag of M&Ms. So we want to know what's the probability that you pull a brown M&M and you eat it and then you pull another brown M&M. So the question that we need to consider to ourselves is, will the second event be affected by that first event? So will the second event of eating or pulling that second brown M&M be affected based on you pulling your first brown M&M? And in this situation, yes, it will. Turns out as soon as you eat an M&M, guess what? There's one less in the bag of all the total M&Ms. And also, if you pulled a brown M&M, there's now one less of those. So when we're thinking about calculating some probabilities here, the probability that we pull our first brown M&M is 7 out of 57. But the probability that we pull our second brown M&M, it changed. It is now 6 out of 56. There's one less M&M in the bag, so now there's 56 M&Ms total. And there's one less brown M&M, so now there's only 6 brown M&Ms. So in order to do the multiple events in this situation, we need to take these 2 and multiply them, but that second event is changed from the first. Remember, if we go back and we look at the dice rolling event that was way the heck back here, both of those events were 1 out of 6. When we're looking at our M&M situation, the second event was affected by the first, so they don't have the same probability anymore. So then we still can do the multiplication of those 2 individual probabilities to get the combined probability. But we had to be a little bit more careful when we were calculating this second event. And that's because this is a dependent situation. So the last and final thing that we need to talk about is the definitions, which are about the words independent and dependent. What we mean here is, was that second event affected? Yes or no? These aren't terms that we need to memorize necessarily, but we should talk about them nonetheless because we might use them in later videos. So an independent event is the outcome of one event. Oh, if the outcome of the first event does not affect the outcome of the other event or the second event. So those 2 events are 100% separate of one another, rolling a dice and then rolling the dice again, rolling the dice and then flipping the coin. Those are separate of one another. You can do whatever you would like to that first dice roll. The second dice roll has its own equal probabilities. However, there are also dependent events. And this is when the outcome of one of the events does, in fact, affect the outcome of the other event. So for example, something like eating. You are taking away from the total when you eat something, or when you choose not to put something back, or when you pick something and then your friend picks something. All of those would be situations of dependent events. And we have to think about those ones a little bit more carefully because that second event's probability is going to be different than the first event's. And that's it.